Let's now explore the binomial distribution, one of the most important and widely used discrete probability distributions. It's a powerful tool for modeling scenarios where there are only two possible outcomes, such as success or failure, yes or no, or win or lose. A binomial distribution is used when 1. An experiment consists of a fixed number of trials. 2. Each trial has only two outcomes, success or failure. 3. The probability of success remains constant for each trial. 4. The trials are independent of each other. The probability of exactly a certain number of successes in a fixed number of trials is calculated using the formula. The probability of k successes is given by the number of combinations of n items taken k at a time, multiplied by the probability of success raised to the power k, multiplied by the probability of failure raised to the power of n minus k. Imagine a factory produces light bulbs, and the probability that a bulb is defective is 10%, or 0.1. If you randomly select 5 bulbs, what is the probability that exactly 2 of them are defective? Define the variables. The total number of trials, which is the number of bulbs selected, is 5. The number of successes, which refers to the defective bulbs, is 2. The probability of success, which is the probability that a bulb is defective, is 0.1. The probability of failure, which is the probability that a bulb is not defective, is 0.9. Step 1. Calculate the number of combinations. The number of ways to choose 2 defective bulbs from 5 is calculated as 5 factorial divided by the product of 2 factorial and the factorial of 5 minus 2. This equals 5 times 4 divided by 2 times 1, which gives 10 combinations. Step 2. Use the formula. The probability of 2 defective bulbs is 10 multiplied by 0.1 squared multiplied by 0.9 cubed. Step 3. Simplify the calculation. 0.1 squared is 0.01. 0.9 cubed is 0.729. Multiply these values. 10 multiplied by 0.01 multiplied by 0.729 equals 0.0729. Final answer. The probability of exactly 2 defective bulbs is approximately 7.29%. Here's another example. A company sends out emails to 10 customers, and the probability of each customer making a purchase is 20%, or 0.2. What's the probability that exactly 3 customers will make a purchase? Define the variables. The total number of trials, which is the number of customers, is 10. The number of successes, which refers to the customers making a purchase, is 3. The probability of success, which is the probability of making a purchase, is 0.2. The probability of failure, which is the probability of not making a purchase, is 0.8.
Step 1. Calculate the number of combinations. The number of ways to choose 3 customers from 10 is calculated as 10 factorial divided by the product of 3 factorial and the factorial of 10 minus 3. This equals 10 times 9 times 8 divided by 3 times 2 times 1, which gives 120 combinations. Step 2. Use a formula. The probability of 3 customers making a purchase is 120 multiplied by 0.2 cubed multiplied by 0.8 to the power of 7. Step 3. Simplify the calculation. 0.2 cubed is 0.008. 0.8 to the power of 7 is approximately 0.2097152. Multiply these values. 120 multiplied by 0.008 multiplied by 0.2097152 equals 0.201. Final answer. The probability that exactly 3 customers make a purchase is approximately 20.1%. These examples show how the binomial distribution is used to calculate probabilities in real-world scenarios like quality control and marketing. By breaking down the calculations step by step, we can see how this powerful tool helps us make data-driven decisions. Next, we'll explore other types of distributions and their applications.